All right, so in 6.5, we talked about a couple more theorems that deal with proportionality. So we talked about if a parallel line connects, or if a line is parallel to one side of a triangle and connects the other two, then it divides the other two into proportional segments. Then we did if there are three parallel lines that intersect two transversals, then it cuts those transversals proportionally. And then we did the angle bisector one, where if a segment bisects an angle, then it cuts the triangle or the opposite side into sides that would be proportioned to the sides of the triangle. So each one of these is an example of one of those. So if I look at one, this is the one where I've got my parallel lines. So what is one way I can set up a ratio to solve this? Because remember, or a proportion, there's more than one way to do these. Chris?
10 over 6 and 20 over x.
Okay, so you went left, right. So 10 over 6, 20 over x, and then I can reduce this to 5 over 3, cross multiply, and divide. And x should have been 12. Anybody set up the proportion differently? Alexis?
20 over 10 and x over 10.
Good. Still got the same answer though, right? Anybody else do it differently? Okay. So I could have gone right, left, bottom, top. Any of those other ways would have worked. All right. 2. So now I've got my parallel lines, right? Parallel lines, cut these into segments that are proportional. What's one way to set up a proportion on this? Go ahead, Chris. Okay, left, right. And then I can say that these are both divisible by 4, right? I can do 3 and 4. And then 3 times 18 equals 4 times x. 4 equals 4x. X would equal, divide that by 4, 1, 3, and 2/4 or 1/2. Alexis.
Can you do like a cross region or no?
Like,
18 and 12. Oh, like 18 and 12.
no, that's the only thing we can't do. So we can't cross. You can go left, right, bottom, top, or the reverse of those, but you can't go across the parallel lines. Okay, Loris.
On the test, are we going to have to find the lengths of the parallel lines?
No. Any other questions on it? So did anybody set it up differently? What did you set up, Madison?
18 and 16 equals x.
Okay, that works. Should have gotten the same answer, right?
Yeah.
And these are the ones, remember you're giving the length of a segment, so you don't want these to be in improper fractions. You want these to be in mixed numbers or in decimals. So that could have also been 13.5 or 13.5, sorry. All right, so 3, you have to know that 1 and 2 are congruent, so it gives you that piece of information. This is now a segment that bisects the angle, which cuts the triangle into proportional, so that this and this would be set up with a ratio with the side lengths. So what's one way to set up a proportion for this? Nick? You don't know how to set up a proportion to that?
10 over 17.
Okay.
And 14 over 1.
There you go. And then I would cross multiply. 17, 14, 68, 238, divide by 10, and y equals, this would be 23.8, or 20 and 8/10, which becomes 4/5. So either of these works. So you only want to use a decimal if it's a terminated decimal, meaning it stops. You don't want to give it a decimal that doesn't end or repeats, because that's not an exact answer. Alexis?
Can you simplify the scale factors? Like you had 10 over, or like for other ones, you simplify it?
So if you, what did you do, 10 to 14? So if I did 10 to 14, then I would be able to simplify it. Yep, 17 over y. You should have gotten the same answer, right? 5, 7, yep. Sorry.
How did 23 become 20?
I wrote it wrong. 23 should have stayed 23. Yep. Thank you. Anybody else set it up differently? All right, so same thing on the test. It's going to give you a diagram or information, and you're going to set it up as it's a ratio, a proportion, and then you have to solve it. This one says this diagram represents a tract of land being developed for homes. Which lot has the greater perimeter? So if I zoom in on this, you've got 3 lots, A, B, and C. So for each of these, I have the bottom, and I have the left side, and then A, I have all of it. So if I were to add up A, it would have been 85, 110, 130, and 80. So 16, 20, that's 405, that's lot A. For B, I'm missing the top side of it. But these are proportional, right? So I can say that 80 over 120 would equal 85 over x. And that's going to solve for this one. So I can simplify this. This would be 2/3 2x. 5, x would equal 127.5. So then I can add up lot B, 120, 110, 80, so this is 200, 110, that's 310, plus 127.5. This is lot B. With me so far? Yep, and then lot C, so there's two options for lot C. What's one? I can subtract, so 371.9 is given to me. If I subtract from that the 85 and the 127.5, it's 212.5. I get 159.4, and then add that to the 150, the 80, and the 40. This is 10, 18, 22, 429 point, and that's a 4. So which of these has the biggest perimeter? B, lot B. Okay, for that last one, for the lot C, I also could have set up another proportion. So if they didn't give me the whole side length, I could have set up another proportion. So I could have gone 120 to 150 over 127.5 over x, and I could have solved it that way. I actually probably would have used lot A. So I would have done 80 to 150 equals 85 to what? Instead of using the decimals. Makes it a little bit easier. Questions overall on the warm-up? Okay, so let's flip to the proof in the homework. Because you're going to have a proof on your test, okay? The good news is it's proving triangles are similar, okay? So I'll show you at what step I would stop here, and if you can get to that step, you're good. So this said to prove that prove that those are congruent based on the triangle proportionality. So you can't use the theorem that says that if those are parallel, then the sides are divided proportionally. It doesn't want you to choose it. It wants you to prove it, okay? So obviously I'm going to start where? Give him. So QS is parallel to TU, and that's given. So if the goal was to first prove these triangles are congruent, or sorry, similar, what are the three ways you can prove that they're similar? Angle, angle, side, angle, side, 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 side. So I know absolutely nothing about a single side length, right? Which means odds are what? Angle, angle. So how can I prove that there's two pairs of angles that are congruent? What's one pair? Chris? Okay, I've got the shared angle R, and so how do I say that R is congruent to R? Reflexive. Okay, one pair of angles that are congruent, right? Because that one is part of this triangle, and it's also part of this triangle. Emily? So if these were my parallel lines, and which transversal are we going to pick? Because it doesn't matter which one, top or bottom. Say top. Okay, what congruent angles do you have there? What kind of angles are you looking at there? Corresponding. So this would be congruent to this. And to say that, I would have to use three letters because those angles are actually not for the Q. I can say angle Q is congruent to angle RTU. And that's the corresponding angles postulate. Now I have two pairs of angles congruent, yes? So what's true about my triangles? They're similar. Triangle RTU is similar to triangle RQS. And my reason is angle similarity. Okay, so if that was the proof on your test, you'd be done. Okay, but this is asking you to go one step further. So what do we know about the side lengths of triangles that are similar? They're proportional. So I can say that or actually let me go in the order that they want it. QT over TR equals SU over UR. And how do we know that? Definition of similar. And it could be polygons or triangles, doesn't matter, because both of them are true. So the proof on your test is not hard, but you do have a proof on your test. Mm-hmm.
Is it like this or like easy?
It's along the lines of this minus step 5. Did you say or easy, though? Because I think that's easy.
Yeah, I just don't want to.
You don't know how bad I wanted to use it.
All right, so test is on chapter 6. It starts with 6.1, which was similar polygons. And in this section, you have to know, obviously, use the definition of a polygon. But what is a similarity statement? List the corresponding angles that are congruent. God bless you. Actually, let me put it in the order of the words that are on your statement of proportionality. So what's the difference between a similarity statement and a statement of proportionality? Because this cost some of you 10 points on your quiz.
Statement of proportionality is good, like the segmented.
Good. Statement of proportionality is what segment over what segment equals what segment over what segment. You're setting up a proportion. What's a similarity statement? Chris.
Like triangle, whatever is similar to.
Good. What's important is the order of the letters, right? So if I wanted to say that A, B, C, D, this is a quadrilateral, but it could be any number of sides. It could be a triangle, it could be whatever it is. If in the directions I already knew these were similar, okay, so obviously you would see something like the figures below are similar, then A, B, C, D would have to match what? I know it's kind of a rough drawing, but look longest side to next longest side to next longest side to smallest side. So what looks like it's A matching AB? So if I were to give this value, and if you want to do that, go for it. It looks like DC is the longest, right? So let's say this is 10. It looks like AB is the next. It looks like AD is the next, and it looks like BC is the next smallest. So AB is the second to largest of that first one. What looks like the second to largest of the second one? So if I did the same thing, if I went and gave this value, this looks like the longest here. This looks like the next longest, then the next longest, then the next longest. And I could have given them totally different numbers, doesn't matter, just an order of what's the longest, okay? So if AB is second longest, what two letters would match AB? HG. And then I went to the smallest side, so I went from AB to BC. So I need to do the same thing here. So that means I have to say GHE. So I can't say it in that order. I have to say G, H, E, and then the last one is F. So I will actually take out the rulers if you want to measure the length of the sides to figure out what's the longest and what's the middle and what's the smallest, or you can match it up with your ID. Do what you need to do, okay? Sometimes it's way obvious and sometimes it's not as obvious.
Are you gonna make it not as obvious?
No. I mean, it's not drastically different, but you should be able to look at it and tell the difference. So corresponding angles, now if I just did this in pairs, angle A would match, which one? G. Angle B would match H. Angle C would match E, and angle D would match F. So I'm going by the order of the letters. My diagram got a little ugly, so it doesn't really look like they match, but you kind of get the point. All right, and then the statement of proportionality, again, I'm going to go by the order of the letters. So AB should go over GH, BC should go over HE, CD over EF, and AD over AF. So the difference between the similarity statement, the corresponding angles, hopefully you know that one, and the statement of proportionality, make sure that you can tell the difference. Okay, so now let's say all these values weren't given for side lengths. Let's say I only Okay, let's say I only gave you those two. Alexis.
The last one would be
AD over, yeah, GF, thank you. Okay. You want to know how to find the scale factor. So if I go around my quadrilateral in this case, at some point I'm going to run into two that I'm given the value of. So even if this said 12, you would want to make sure you match up the right sides. So the smallest to the smallest would be 8 to 4. Pay attention to the directions. If it says to give it from A, B, C to E, F, G, H, then I would have to do 4 to 8, which is 1 to 2, or 1 over 2. If it said from E, F, G, H to I, A, B, C, D, what changes? So if I said, give me the scale factor of E, F, G, H to A, B, C, D, it flips it, it would be 2 to 1. So pay attention to the directions, okay? If it didn't say it either way, it just says scale factor, then you could give either answer. And then let's say I had a value that was missing, like x, and it said to find x. So I would say my scale factor, which is, we said 1 to 2, would equal x to 12. Cross multiply and divide. If you get a fraction, and you are going to get fractions, you want to make sure it's in mixed number format for the length of a side. You know I'm doing a test review, right? Okay. Questions on 6-1. Okay, so then 6-2, we skipped, and we went straight to 6-3, which was angle-angle similarity. Okay, and then in 6-4, we did side angle side. And side, side, side. So these were 3 ways to prove that triangles are similar. The first is if you have 2 angles that match. The second would be if you had 2 pairs of sides that were proportional and the angle between them congruent. And then the last one is side, side, side. So if all 3 pairs of sides are proportional, then the triangles are similar. Are these triangles similar? Yes. Why? The vertical angles would give you angle, angle. So if I asked you to write a statement of similarity, and I started with ABC, what should the order of the letters on the other side go? EBD. And if I asked you to verify why, you would tell me angle, angle, similarity. Are these triangles similar? What piece of information do you know that's not already marked? The vertical angles. Is this side angle side? No. What's wrong with it? Not the included angle. So these would not be similar. Are these similar? Yeah. So now it's the included angle, right? Are these similar? Yes. And the reason? Side, side, side. Proof will come from this section we talked about already, right? So you're going to get a proof in which you've got to be proving triangles are similar. So know the 3 methods and then figure out how to get there. It's pretty much what you've got to do. Okay? We've seen a bunch of different stuff. We've seen parallel lines come back into play, so make sure you know that. Make sure you know your vertical angles. Make sure you know reflexive angles, all that sort of stuff. You could see an angle bisector. So all the stuff that we've been, God bless you, all the stuff that you've known up to this point, you could see. If there was a midpoint, you would know maybe the sides are congruent, stuff like that. So just make sure. I'm not going to throw you a curveball, like something you haven't seen since chapter 1, but make sure you know things, obviously, outside this chapter. Okay, and then 6.5 is what we talked about yesterday. So 6.5 had your triangles with parallel line. So this would divide this into proportional sides. So A over B would equal C over D. God bless you. Or A over C would equal B over D. What threw you guys is if you got thrown in those, right? So can I say A over E equals B over F? No. I have to say A over E equals what? Nope. Nope. So A over B, which you have to look at that when you're involving the part that's not split. So if you're involving the side that is not split, you have to look at them like they're similar triangles. So A over E would equal what, Loris?
A plus B.
A plus B over F. Good. So when you're involving the side of the triangle that is not split into parts, you have to use the whole side of the triangle. So if I said C over E, it would equal what? Good. C plus D over F. So when you're using the 2 sides that are cut into pieces, you could use it in multiple ways. But when you're using this side that's not, the side that's the bottom of the triangle or the right side of the triangle, whichever one is not split into proportional parts, you have to treat it as though it's 2 similar triangles. Questions on that one? Okay, then you had the parallel lines. So 3 parallel lines, 2 transversals. Oh, it was used to prove that you mean that the converse to this?
Oh, no, I thought it was two parallel lines.
It has to be, no, 3 parallel lines, 2 transversals, yep. Because the transversals don't have to be proportional. So when this is done, I could say A over C would equal what? B over D. I could say A over B would equal C over D. I could go right, left, B over A equals D over C, or bottom up, so C over A equals D over B. Could do that in any of those orders. And then the last one was the angle bisectors. So if you've got a segment that bisects an angle, it cuts the side opposite into 2 parts that would be proportional to the sides of the angles. So A, B, C, D. I can say A over B would equal what? D over C. I can say A over D would equal what? B over C. Or I could flip either of those. I could say B over A equals C over D, or I could say D over A equals C over B. The only other theorem that was in there was the converse to the first one, which said if a line cuts the triangle into 2 parts that are proportional, then the line would be parallel, okay? But you won't need to use it, you're not going to use it in a proof or anything like that. Okay, it'd be the other way around. Questions overall on chapter 6. So your test is only 11 questions, because don't look at me like that. Everybody else only has a half hour. What do you want me to do? It's got 11 questions.
Why is there only half hour?
So it's a math day.
Oh.
So they only have a half hour.
Wait, we have your first period?
You have me first period, but Mr. Carlson has classes after that only have a half hour. So it's a test. Listen, there's no difference. You either know it or you don't. So either you know it for 11 questions or you don't. Or you know it for 20 or you don't. Okay?